Okay, welcome to data structure. Hi, I'm Swapnil Chaudhary. Today we are going to start with our new chapter or new unit number 4, that is linked list. That is linked list. Okay, so we have studied so far array representation of stack and queues, but array have the following weakness. There are some weakness associated with the array. So first weakness of array or problems with array is array have fixed dimension. Array have fixed dimensions. Okay. Once the size is decided at the time of declaration, it cannot be altered during the execution. Okay. Once the size of array decided at the time of declaration, it cannot be altered or changed during execution. Okay, so this is what first major problem with array. Now second problem, if you have reserved the space of 100 elements, but use only 10 then the remaining 90 locations cannot be used. For other purpose. That means they are wasted. If you have reserved 100 element space and out of that you are using only 10, then the 90 locations cannot be used for other purpose. Okay, means what? That memory location are wasted. We cannot use it till the execution of that particular program. This is the second problem. Now problem number 3 is what? The element of array are stored in a continuous memory location. Okay, the elements of the array are stored in continuous memory location. Continuous memory location. At a time, it is possible that continuous memory is not available, even though memory is available patches. Means continuous memory is not available sometimes, even though the memory patches are available. Okay. Now, next problem with array is what? The operation like insertion and deletion. The operations like insertion and deletion on arrays is tedious. Very tedious, because it requires the elements in the array to be shifted, which is not feasible. Okay, or if you are inserting at the last position, so you need to traverse till end of the array. So these are what the problems with linear array. This is what problems with, you can say, arrays. These are what problems with array. To overcome these problems, we are going to, so first thing is what? It is a static allocation. Static allocation. Okay. It basically follows static allocation. Means while the runtime, before the runtime, we need to specify the size of that array. The major problem is this. Okay. So these are what the problems with array. The first one is a static. If you allocate 100 memory location and use only 10, then 90 will be wasted. We cannot use that 90 location for other purposes. Other purposes means any other operation you are going to perform. For that you cannot use it. The elements of array are stored in a continuous memory location. This is one again the problem. So sometimes what happens, if this is what your memory means, RAM. Okay, so if you want to allocate 5 continuous 5 memory location, but suppose if you have some values in that already, so here what happens, there is no continuous memory location to store 10 array, even though there is some patches of memory location is available. So because of continuous memory is not available to store 20 elements, where our array will not be allocated the memory. So this is what a problem with array. Okay, so to overcome these disadvantages or problems because of problems of array, we are going to learn linked list. We are going to learn linked list. So the linked list can be grow and shrink in a size at the time of execution. The most important point is what? So this is what it is, a static memory allocation means before executing that program we need to allocate the size of array. But in terms of linked list, okay, so in linked list what happens, the linked list can be the first benefit of linked list is what? The linked list can be grow or shrink in the size at the time of execution. Okay, so what does that mean? The linked list allocation is dynamic. Linked list allocation is what? Dynamics means what? We can allocate and deallocate the memory size while we are executing our program. Okay, so this is what? Dynamic in a nature. The most important point related to linked list is what? Dynamic in a nature. Okay, the elements or you can say nodes. Okay, the elements or you can say nodes. Okay, so we are going to see the what is nodes, okay, of the linked list. Linked list are not stored in a continuous memory location. Are not stored in a continuous memory location. Okay, because of which we may never fall short of memory. Because of we may never fall short of memories, since it is not a continuously allocated. And insertion and delete the node in the linked list does not require shifting the node, which means that is not the tedious job. Means while we are deleting or inserting the node, we doesn't need to shift the elements in the linked list. We are just change the pointer value at this locations and just put respective node or delete a respective node from the linked list. Okay, So what is the linked list? So you may ask this question, sorry, what is linked list? Okay, so linked list is a very common data structure used to store similar data in a memory. The most important thing is what? Linked list is a very common data structure used to store similar data in a memory. The element of the linked list are not stored in a continuous memory location. They are scattered all over the memory, but these elements are still bounded to each others. Okay, they are scattered in a memory, but these elements still bounded with each other. This ordered and bounding between the element is maintained by explicit link between them. Explicit link between them. So we can say each item in the linked list called node. Okay, each item in a linked list, that is we call a node. That is we call node. Each item in a linked list, that is we call a node. It contains two fields. It contains two fields. Okay, this node contains two fields. One is a data field and other one is a next address field. Okay, one is what? Data field, which store the actual data value, or you can say information. And this field, the second field, that is address field, which basically stored the address of next node. And this is what? This is what? Node structure. This is what? Node structure. So what is a node structure? Which contains two fields. One is a data field and other one is a next address field. Okay, this is what? Next address field. So basically, suppose we have a two nodes. The first node address location is 201 and another node address location is a 110. Okay, so address of, so this is what the next node of this node, the node 1's next node is this one. So address of this 110 is stored in the address field of first node. So 110 is stored here. So basically this node will going to point the next node. So in this way, these two nodes or other nodes are linked together. So if you are going to see the real life scenario, the railway, or you can say train, is the best example for that. There are two different compartments that are linked to each other, or you can say the chain whereby everyone chain. Okay, so in that every node are linked to each other. So the first best real-time example is what? Railway. Two compartments are joined to each other. Okay, so this is what a node structure. This is what a node structure. Now what we are going to do, that the most important thing, you may wonder how we are going to implement this node structure in a programming language. In a node structure in a programming language, as we study data structure using C, data structure using C programming, we are continuous with the C programming. So I will going to explain how we are going to implement this node structure in a C programming. So for implement this node structure, we are going to use struct, and whatever name you want to give to that particular structure. So struct, so struct, I'm going to write it again here. Struct, and whatever name you want to give to that particular structure. So here I am defining one structure which is used in C programming. Okay, that is user defined data type, that is structure. So I name it node, capital node or small node, whatever you want to give. And the first field is what? first field is what? Data field. And suppose if I am going to insert integer value in this data field, so I need to define this structure as a integer. So data field as a integer. So integer data. Okay, so name it data. Okay, semicolon. Okay, name it data with and ended with semicolon. Now what we are going to do, we are going to define or implement the second part. See, what we are going to do here, we are going to implement this node in a programming language. We are using C programming. So that is why I am using structure keyword or structured variable. Variable name, structure data type. So this is basically user defined data type. So I wrote struct. This is a keyword of C programming, and node is a name which is I assigned for that respect to structure. Now here I'm going to define this linked list as an integer data value which holds the integer data value. That is why I use here integer data type, and the name of that data field is data. And the next part of this link node structure is what? Linked to the node structure, means which basically hold the address of next node structure. Okay, so this field basically holds the address of next node structure, and that node structure is similar to this node structure. So what I am going to do here, I am going to use recursive structure definition. So here I am going to call same structure struct node. Okay, and this is point to the you may write here the name of this structure pointer variable is a node, or is a link or next. So I am going to use link. Okay, since it is linked to the next node, or you can put next keyword here also. So what I did here, I recursively call this structure definition. I recursively call this structure. See, this structure calls itself, but here we are just declaring the pointer variable. Here we are declaring the structure type pointer variable. This is, see, asterisk. I am writing here asterisk. So structure type pointer variable. Why I am using pointer variable? Since it is a whole address of next. So the main point is here is what? We cannot store address value in ordinary variable. So what I required? Pointer variable. That is why I am declaring this pointer variable, which is a type of structure. Since this address field basically hold the address of next node. Okay, so that is why this completely node structure is address of this node structure is stored in here. So we are storing address value. So that is why I am using pointer variable. This is what? Pointer variable. But that pointer data type is what? This variable data type is what? That is structure type. The base example for this, if I am declare in my C programming language, I declare one integer variable a which holds the value 10. So this is what? Integer variable that I declare. The name of that variable is a, and here I am stored the address value 10. Assume that the address location of this a is 9691. Okay, the address value is what? 9691. Now suppose if I want to store the address of this variable, what I need to do? I need to declare the another variable which hold the address. So that variable is pointer type, since we are storing the address value. So that is not an ordinary variable. To store any address location, we always declare the pointer value. So this is, suppose I declare one variable, pointer type variable. Okay, the name of that variable is b. But the most important thing is what type of this pointer must be? This pointer must be the integer type, since it is hold the address location of value integer. So I need to declare this pointer is also integer type. Same logic we use here. Here we are going to store address of next node structure, complete node structure. Okay, address of next node structure. So the data type of that pointer variable the data type of that pointer variable must be node type. So that is why I write here struct node. So this is what a structure definition of node implementation in C programming. Implementation of node structure is this. Okay, so what I am going to do, I am going to write it again in the next page, so you will be clear that. Okay, so how I am going to write it? Okay, struct, you can name it node. Okay, this is structure definition, so that is why we are writing opening and closing parenthesis. So whatever we are going to write in a structure definition, that is in between this opening and closing parenthesis. Then the data type of data value we are going to store in that linked list is type of integer. So that is why I am declaring integer data field. Integer data field. Close with a semicolon. Then this structure is pointing to the same type of structure node, node type structure. So that is why I am writing the recursive definition. So struct, here write it again node, but we are pointing to we are storing address location. So that is why I am declaring here pointer variable. So link. Got it? So this is what a structure definition, and I am terminate this structure with a semicolon. This is a mandatory. Always terminate structure definition with a semicolon. So this is what a node structure. This is what a node structure of linked list. So this is what basically, if you draw graphically representation of this code is like this, simple. This is the data field and this is what link field. We stored the address of next node. Okay, now in next lecture we are going to see the basic operation which we are going to perform on this linked list is like append, insert front, then delete, okay, insert after, insert before, then reverse, then search operation, then we are going to find the length of linked list, then display it. So these are what basic operation we are going to implement in a linked list. Okay, so that's for today. Thank you very much for watching. Have a good day.